Okay, in here this is our practical values. So then we had to find four parameters. One is our delay of our circuit. So in delay of this our circuit we can find using RC time constant charging equation. What is the equation is Vc equals Vs times 1 minus e to the power minus t divided by RC. This is our charging equation. Then T is our time delay. So what I'm going to do, I'm taking this minus t divided by RC as x. So why? Because to get the do the equation, solve this equation very clearly. So now I'm applying my voltages. So in here I'm using 9 volt xenon diode. So this is our circuit like. So here voltage now is I'm taking as 9 volt because 5 millivolt is not usable. It is not effect to our circuit. We not get that. So I'm taking as 9 volt, and this voltage we can take as I'm taking as 0.67 volts. 0.67 volts. So in here total is here on this capacitor. So capacitor voltage we can take as 9.67 volts. So that is the method to get that voltage here. So now I'm applying 9.67 and Vs in here I'm neglected 6 millivolts, so I'm taking as 10 volts, no problem. Then apply 1 minus e to the power x. So this is the normal equation. So I'm erasing this one, and our x is minus t divided by RC. So we have to solve this one. In here 10 is easy to divide. So 0.967 equals 1 minus e to the power x. Then I'm taking this x 1 to here. So I can take it minus notice I will take this one, Ex equals 1 minus 0.967. So according to my calculator, I can type it as 1 minus 0.967. So what is the value is 0.033. 0.033. Then this is the 1. So then we have to find the x value. So what I'm going to do, I am applying both sides of this equation. I am applying logarithm basic theory. What I am going to do, I apply log e to the power x equals log 0.033. So then x I can take into here. So x log e equals log 0.033. So then we can take x value dividing by this one, divide by log e. So then I can find the x value. So I'm applying in calculator log 0.033, then divide by log e. So what is the value is minus 3.4112. So value is minus 3.4112, more than enough. So now we have to calculate this value. So then I can similar this one. I'm taking it into here. then I had to find the RC value. What is RC? It is we take as a time constant. So what is the R value is 1841 ohms times C is 2170 microfarad, means 10 to the power minus 6. So this is the RC value. So I am easily applying to calculator. 1841 times 2170 equals, then I divide by, so what is the value is it's around 3.9949. 3.994. Okay, so I'm applying to this one to here. So what is the value is 3.4112. I have some minus value, so minus t divided by 3.994. so I can find easily time is, our delay is now is coming 3.4112. okay, what is the value is 13.6 seconds. 13.6 seconds. So this is our time of this delay of this circuit. So in practical we test this value with this resistor, capacitors and these, so those things, and we can find the value is equal to our time, this time and our practical time. Then its circuit is, we can say circuit is perfectly work. So now time is okay. So now we had to find the discharging resistor. So now I'm going to do that. Okay, I will erase this old one. So 3.994 I will erase. That's nothing to worry. Okay. In discharging, I'm talking about that one. In discharging, there I have this our capacitor also basically. Then we have a diode here. Then this is our R dash. This is our C value. In here, voltage drop, I take it as 0.55 volts, no problem. And this here have R dash C. And also in this point is voltage is last 10 volts in the working stage of the circuit. So don't forget that. It's very important to this circuit. In design of this circuit we have to consider the voltage in here is the most first one to take that value. So what I'm going to do to find this R dash, easily, no problem, we can apply discharging equation. What is that? Vc, I'm taking as Vc dash as the discharging end, Vs dash e to the power minus T over Rc. This is our discharging voltage of the capacitor equation. So according to this equation, I can apply and I can find the I can give the time value something, I can give the voltage of the something, then I can apply. But we cannot do that into here. Why? Because 10 volt is I told you it is very important to calculate here. Let's see what happened in here. Actually, what is happening here? If I provide 10 volts in normal circuit, we know there have some resistance. This is the connection of this R value. Then we can find that this value and in here, normal condition, in working condition, if we are to provide the voltage to the circuit, then it will charge up to 10, it in here have 10 volts. So every time there have some inrush current into that resistor. Every time there have 10 volts reference in here, it's also grounded, so grounded means 0 volts. According to this 10 volt, this resistor is flowing some inrush current. We call that the inrush current. Why? Because it is not usable to us. There's nothing. It actually is also dissipated to as a heat. There's nothing to do. We cannot do anything to do that one. It is also flowing in this resistor every time. Every plus 10 volts in here, then current is flowing. So actually, it is very it's very important to in our circuit. Normally, in our resistors, we can take as quad watt, half watt, 1 watt, 2 watt, as a 5 watt also, as a 10 watt also. You can use in resistors that kind of wattages. So normally we in circuits we use quad watt and half watt or 1 watt. So normal values into here. So I'm taking that point. What is my point is that voltage is I take as this to circuit. Then I can find some resistor value. So easily, normally we take in 0.25 watts resistors every circuits. So I do this calculation using this voltage value. So if you want use any other voltage, you can use, no problem. I will tell that to you what is the point is in that voltage value. That is the point. That point is easily you can find that T value, delay of that circuit is how fastly discharge the capacitor. So it depends on this voltage actually. It's depending on this circuit is depending on this, that time value is dependent on this voltage value. So we have to consider that voltage value most probably, most first rate. So what I'm going to do, in here 10 volts have, in here 0.25 watts have. So we have to take some resistor, it's not to be damaged. If I increase the current in here, the voltage is here, if I take some resistor more than 0.25 watt heat energy, if I take 0.26 watt energy from that resistor, it's also burned. So what I'm going to do, I'll take it as some percentage of the voltage. So I'm not going to percentage actually, I'm taking it as 0.2 watt. I think it's much better. Why? Because 0.25 watt we cannot exactly use, somehow some dependent of this regulation. If the voltage is increased, the resistor also get damaged. Otherwise also 0.25 watts means the near of the that burning point. If somehow it increase some energy again, somehow resistor is also burned. Otherwise is that is the heat is that voltage as taking as out of that heating. So some time of some we take as something 1 year or something, then resistor will also get damaged or something. So we had to do some perfect calculation and then find the better value. So I'm taking as 0.2 watt. Why? Because there's no probably can happen some cases. So I'm using 0.2 watt. Then how to find the resistor value? Very easy. I can apply P equals V squared divided by R. Our voltage calculation equation. In here 10 volts. So I apply here 10 times 10 divided by in R I take it to here. R is equal then P is 0.2 watts in here V squared. So easily I can put into calculator. 100 divided by 0.2. What is the value is? 500 ohms. Our value is 500 ohms. So you can easily find the 500 ohms easily. So in practical, there's no 500 ohm resistors. We know no. So I can get 560 ohm resistor. No problem, no issues. So if you won't use 470 ohms, the voltage is somehow increased. So if you want, you can use 1 watt or something. Then actually voltage is increasing. The time of the discharging is actually reduced. So that is a very fast method. Actually, it's the fastest is then depend on this voltage, not other situations. Discharging time is dependent on this voltage only. So now we have to apply to here and find that that resistor how much take that time. So what I'm going to do, I'm erasing this circuit. Then after fully charge this capacitor, in here you know voltage is, I'm using this one, and I take it R dash as 560 ohms, no problem. In here voltage is fully charged, 9.67 volts we take. So then what happened after disconnected these parts? Then there's no 10 volts reference. Current is flowing upwards. So flowing to this and destroyed something somehow. So then we can apply our discharging equation. What is the equation? Is Vc dash equals Vs dash times e to the power minus t over Rc. So in here, what is Vs dash and what is Vc dash? So actually Vs dash is the supply of this circuit. Actually in here supply means the capacitor is act as a supply. So that voltage is, we can take it as Vs dash. In here 9.67 volts is the supplying something, doing dissipating the voltage. Starting voltage is the 9.67 volts. So Vc dash means we can take that minimum value of the time. We can calculate how much is the best range. So if we consider this circuit, if somehow 0.56 volts, also this diode is conductance. You know the diode characteristics curve is likewise in your end is going to increase gradually, not perfect 19 angle, some gradually increasing. So if we take this is the value. If that starting point is now our 0.5 volt according to this diode, practical diode. So then after what happened means there have the conductance is actually stopped, not perfectly stopped, somehow stopped. So if I take 0.4 volts, then what happened? The current is flowing is actually very low. So we can tell somehow after that dissipated this current in after infinite, not infinite, but if somehow some time of delay, it's also depend on that 5 Rc time actually. Then after that time, it's not actually depend 5 Rc, but they have some diode. So it's some other reason. So somehow it's near to that one. We take it as, but not perfectly. somehow the minimum I want to tell you this minimum voltage requirement is 0.5 volt. That is the conductance of normal act as this times like RC constant like acting as in that point only 0.55 volts. Then after it will gradually simply reduce that current flow into this circuit. So in here R dash is 560 ohms, no problem. So we have to take the minimum voltage. What I am going to do, I am taking this value 2 into here. We take that much value is better than to circuit as act as somehow better discharging point. So I am taking that value as 0.5 volts. I take it as take that 0.6 volt, no problem. Easy. So what I am going to do, then I can apply e to the power minus t over RC means minus t. We had to give some no, t is the our target value. What is we want to find out how much time to wasted to that discharging of the capacitor around 0.6 volts. So what is RC value? In here R is 560 ohms. Don't use this resistor, you have to use this resistor. Why? Because it is a charging circuit. So 560 ohms in here I take it at R dash no. So R dash C we can calculate as 560 ohms times 2170 microfarad, which means dividing by 10 to the minus, and I will put into the down. So then we can find that value 560 times 2170 equals 1, and then divide by that value. So what is the value is 1.2152. I'm writing in here 1.2152. So now we can easily find that minus t divided by this minus t. So same calculation. So I will divide from this one and find the value. Now I am erasing this circuit. .6 divided by 9.67. The value is 0.062. 0.062 is a value. Then it equals, I take it as also it as a e to the power x. Then we have to find the x. So I am applying logarithm to both of sides. Log 0.062 equals log e to the power x. Then I can take it as x, and what is the value is log 0.062 divided by log e. So log 0.062 divided by log e, then value is minus 278. Minus 278. Perfect. Okay, now is the x. So what I'm going to do, I'm applying to here minus t over r dash c is we take it as what is the value in here? I forgot that value. We have to calculate again. 560 times 2170. 1 point, where's that value? Here 1.2152 equals to minus 2.78. Then we can take the t 2.78 times 1.2152. It's around to 3.3 seconds. Is near to 3 seconds. So this is our discharging time of our capacitor around 0.6 volts. So it takes 3.3 seconds. So you have to remember that voltage value. If the voltage value is increased, then simple T also will decrease. That means the circuit is very fast discharging. If I not use something, then I cannot get that much of time. If I use that circuit is perfectly, we can take into more than into here. So now we have to find T also is there. Okay, what is also okay. Now another case here. If the voltage is increasing, that's mean our regulator is like I think remember 7 8 10 0. So there's this. If the voltage is increasing of this resistor, then it will conduct more current. So if you design this circuit, you have to find is that enough not, is that okay, that current is flowing through this. If somehow if you know this is this resistor value is 1 ampere. So this IC value is maximum current is 1 ampere. If I flow through, like if we take 100 milliamperes, so you can only take another much is 900 milliamperes only. If somehow I use as a 800 milliampere for here, 200 milliampere is flowing through this one. Anyhow, this IC will get increase that heat. So if you design this circuit, you have to consider these points. It's very important. Okay. Now we had to find that of the transistor beta value. In here we measure the beta value. It's around 3.67. I can remember. This is very important of the design of this circuit. If we take some X load, I'm not putting that one, I'm taking X load. What is the load? Actually in here we using relay, 9 volt relay. In 9 volt relay approximately it's take 30 milliampere to get start that work, and perfect one is take around 30 milliamperes. So in our IC means in here is the IC is 30 milliampere. We take it as other one is this resistor. If I take this R, no problem, keep it in here. And you know this is voltage. This voltage around I take this as 9 volt. In here I take this as 0.67 volts. So total is 9.67 volts. So we have to apply some basic transistor biasing equation. So what is that? This resistor voltage plus this voltage equals to 10 volts. So I don't know this resistor. If I don't know this resistor value, so I am taking it as IB. Somehow we can find that IB, and then I can apply to here. Then I can take the resistor value is more than enough or not. So its IB is dependent on that one. In here, I think I better to use find IB. So I'm taking in R as a 1.841 kilo ohm. So now I'm applying that equation to here. What is that? 10 volts Kirchhoff law, no problem. I take the 10. 10 equals this voltage means IB times what is the resistor value, 1.841. I take it as ohm. It's so easy to calculate. For 1 multiplied in here plus this voltage is 9.67. So one can find the IB value easily. What I'm going to do, 10 minus 9.67, the value is, you can get 0.33. Then I can divide by 1841. The IB is around 17 milliamperes. 17 milliamperes. No problem. So 17 milliamperes. If it now IB is, I can take into here. It is the maximum 17 milliamperes of the flowing through this circuit. So now the maximum in here beta equals is IC divided by IB. Now I can also find IB in that one because we know IC value and we know the beta value. So then I can find IB easily. IC means 30 times 10 to the power minus 3 divided by beta is 367. So I can take the value. What's the value? 30 divided by 367, 3 by 0. The value is it's around 80 0.8 microamperes. So IB is a too much small current to control the 30 milliampere to here. So according to here, 70 milliampere is more than 2817 of microamperes. So what is that? Circuit is working perfectly, no problem. The current flowing to their hand, then it will can make that much current. Is the maximum current I will calculate as a 70 milliampere to apply to here, and then I can find the IC. If you want, you can do it. I'm not going to do that. So that's how the every calculations in here. So let's go to do the practical and find what is the time to take that delay.